Now this is another example for which we could use this formula. But the problem with this formula is, in this particular case, my value of r here would be -1. So it would be 2 times 3x minus 2 all to the power of -1. And we know that if we have -1 on the bottom, on the denominator of a fraction, then horrible things happen and we all lose our lives and bridges fall down. So therefore, there's another formula that we need to use. And here it is. Now, this is based on the idea, remember, that the derivative of a log is 1 over x. So therefore, the antiderivative is going to go the other way, and we're going to get a log. So when we know that the power of x on the bottom line is 1, or the power here, r is -1 in the other formula, we're going to end up with a log. Once we've worked that out, we can pretty much go along the way we did in the previous example. So here, what I'm looking at is essentially, for this formula, a is 3 and b is -2. And we're doubling it. So it's like we've got a 2 out here. Okay? So then we can say that the antiderivative, using this idea, the antiderivative of 1 over 3x minus 2. Now bear with me, I know there's a 2 here, but bear with me, it's alright. This is the same if I write a 2 out the front, there's my constant that's come out the front. So this is ultimately the way I'm going to use this formula. Then I can substitute my values in and get my answer. So then it's 1 over a, so 1 over 3 times log e ax plus b 3x minus 2 plus c. And all of that is doubled. So therefore we get 2/3 log e 3x minus 2 plus our constant, whatever our constant is. And that's our answer. Don't worry too much about the idea that this c isn't a 2c. It's just whatever constant it is. So any number will do. Don't worry about that. In fact, if you want to be really, really finicky mathematically, you could call this one now k, where that's a different constant from the constant you use there. And that sort of understanding will have the examiners grinning from ear to ear.